In today's video, we are going to explore the concept of relative formula mass and understand the types of calculations you may be required to perform during your studies or in an exam setting. First, let us quickly recap a few key ideas from earlier lessons which will help us grasp this topic better. When we talk about the mass number of an element, we are referring to the total number of particles found inside the nucleus of an atom, more specifically the sum of its protons and neutrons. This number is often located at the top left corner of the element's nuclear symbol on the periodic table. However, in some cases, instead of showing the mass number, the periodic table might list the relative atomic mass, also called the average atomic mass, and represented by the letters A. The relative atomic mass is a weighted average of all the naturally occurring isotopes of that element based on how abundant each isotope is. In nature, for example, while individual chlorine atoms can have a mass number of either 35 or 37, the relative atomic mass of chlorine as a whole element is 35.5 because it reflects the average mass of those two isotopes, taking into account their relative abundances. Now, this is all very useful when considering individual atoms, but when we need to calculate the mass of an entire compound that contains multiple atoms of different elements, we use what is known as the relative formula mass, which we represent with the letters M, R to calculate the relative formula mass of a compound. All we need to do is add together the relative atomic masses of each atom present in its chemical formula. For instance, let us look at magnesium chloride, whose chemical formula is written as magnesium chlorine 2. This means it contains one magnesium atom and two chlorine atoms. The relative atomic mass of magnesium is 24, and that of chlorine is 35.5. So, to find the M/R, we simply calculate 24 plus 35.5. times 2, which gives us a total of 95. This tells us the relative formula mass of magnesium chloride is 95. Let us take another example, which is sulfuric acid, written chemically as hydrogen 2 sulfur oxygen 4. This formula tells us there are 2 hydrogen atoms, 1 sulfur atom, and 4 oxygen atoms. To calculate the relative formula mass here, we do 2 times 1 plus 1 times 32 plus 4 times 16, giving us a total of 98. So the M/R of sulfuric acid is 98. Now, sometimes you might also be asked to calculate the percentage mass of a particular element within a compound. This simply means finding out what portion of the compound's total mass comes from one specific element. To do this, we use a straightforward formula, which is the relative atomic mass of the desired element multiplied by the number of atoms of that element divided by the relative formula mass of the entire compound, then multiplied by 100 to convert it into a percentage. For example, let us calculate the percentage mass of sulfur in sulfuric acid. As we know from earlier, sulfur has an AR of 32, and there is only one sulfur atom in sulfuric acid which has an M/R of 98. So the percentage mass of sulfur would be 32 times 1 divided by 98, then multiplied by 100. This gives us approximately 32.7%. Now, to finish, let us look at the percentage mass of oxygen in a different compound, calcium hydroxide, whose formula is calcium oxygen hydrogen, taken as calcium open bracket oxygen hydrogen close bracket 2. In this formula, the subscript 2 outside the bracket applies to both the oxygen and the hydrogen, so we have 2 oxygen atoms and 2 hydrogen atoms. The relative atomic masses we need are 40 for calcium, 16 for oxygen, and 1 for hydrogen, so the mass contribution of oxygen would be 16 times 2, giving 32, and the total M/R of the compound would be 40 plus 32 from oxygen plus 2 from hydrogen, giving a total of 74. So we do 32 divided by 74, then multiply by 100 to get the percentage, which is approximately 43.2%.